Assalamualaikum and a very good afternoon. So we continue with the last topic on life cycle costing. Okay, go to the next slides. Okay, this is just an introduction. Basically, the purpose of life cycle costing is to calculate the overall cost, not just the initial or the construction cost, but in life cycle costing, we consider the overall perspective of a cost. From beginning until the end, until the demolition. So this one you can read it on your own. Okay, the life cycle cost famously being connected to the iceberg. If you look at the iceberg, the cost that you can see is just a small portion of the actual size of the iceberg. Similarly with the life cycle costing. So the top portion that you can see, for example, this is the Titanic. They just see the small iceberg, but actually the cost or the overall cost or the life cycle cost is beneath the oceans, which includes the energy cost, maintenance, repair, renovation work, and so on. So it is important to look in the life cycle perspective in order to get the value for money in the long run, in long term. So this is just cost that incurred in a building life cycle. So this one is more comprehensive. This one is the term cradle to grave. Cradle to grave. Cradle means starting from the earliest process, which is the birth. So in this case is the raw material acquisition, the mining and so on, until the grave, the renovation or demolition work. So each process has its own cost, has its own energy consumption and impact. But in life cycle costing, we just measure the total cost, not the energy and environmental impact. Okay, this is the same thing. So life cycle cost is a sum of initial costs plus associated costs plus annual running costs and maintenance costs. So you add up all these things, that is the total life cycle cost. Okay, this is the elaboration on that. So what is initial, what is running, what is occupational charges. So this one is self-explanatory. You can read it on your own. So what is the application of life cycle costing? So the first application is, number one, is to when you have different sites or different design proposals. So either you want to construct a building by using design A, or a little bit more complicated, design B. So design A and design B, which which has the lowest overall cost. So if you just take into account the initial cost, probably a design B will be the cheapest. But if you want to look at the overall life cycle cost perspective, probably another design is more economical. So if you compare these two with the operating cost, with the maintenance cost, you can justify which location, the sites, or which design is more economical. Then the second one is to compare whether it is more viable to refurbish the existing building, or you just demolish and construct new buildings. So which one is more economical? You have to look at the cost of repair, the cost of um, mechanical, electrical, and so on. So in order to justify your decision, life cycle LCC can be one of the uh, tools that you can use. Number three is to compare alternative materials. For example, a building, whether it is more economical to use carpets or to use ceramic tiles. So which one has the advantage in terms of cost? Which one has to replace frequently compared to different type of material? So this sort of things. Remember, I think in part 6 also you learn about this. When you compare, normally you compare um, the air conditioning system, whether you should install the um, inverter system or just a standard system. Which one has the lowest LCC between these two? So if we compare the initial cost, of course the conventional air conditioning is the cheapest. But if you look at the um, life cycle cost perspective in the long run, so most probably the inverter will be um, cheaper in the long run. Number four, whether you need to do any renovation, extension or modification. So each process, which one has the most value in terms of life cycle cost. So you can use LCC to do that. So the objective, I think this is you can read on your own. Okay, and same. This is self-explanatory. Okay, the different stages of LCC, you have three stages. Number one is life cycle cost analysis, LCCA, whereby you use historical data or the cost of the similar type and size of building as a benchmark. So you use that data to predict what are the actual costs that will incur to your project. Okay? The second one is the life cycle cost management, so LCCM. So which this stage identify any costs that can be reduced over time. So you propose to the clients, so which of the items from the historical data in the LCCA to identify which elements that can contribute to the to reduce the cost. And the last one is life cycle cost planning, which is to identify the total cost of building, and also you plan the timing of work and expenditure of your project. Okay? So by using LCCA and LCCM, and then you construct your own life cycle cost for building. So that is called life cycle cost planning. So this is the concept of life cycle cost, as I mentioned earlier. You can read it on your own. This is actually from PM Khairani's book, the I think the red book. So factors to consider in life cycle costs. So number one, you have to consider the investment lifespan. So how long is the investment? For example, if you plan to construct a commercial building and you plan to stay there for 30 years before you sell it, so the investment lifespan of 30 years must be is considered in your life cycle cost. Okay, but normally for normal users, for residential building normally is up to the leasehold period. Normally is for up to 99 years. Okay, depends. And then the second one is the building lifespan. So how long does the material will last? How long does the building can be um, soundly, the structure is still good to stay in the building? Which materials or which elements have to maintain more frequently than the others? So you have to identify these things, these factors. And then the component lifespan, which component has the um, longer lifespan compared to the other components. For example, for painting, probably you need to repaint for every 5 years. Um, and then for roof truss, for example, maybe it lasts up to 30 years. So you need to, if you plan to stay for 60 years to the building, so you have to estimate you after 30 years you have to replace the roof trusses. So these are the things that need to consider. The data for lifespan of component is available, but for Malaysia is quite is still lacking. The one that I found is from a study by forgot the Developers Association of USA, I think. They have listed out the material lifespan. And then the interest rate. So when you do LCC, normally you will use present value method or annual equivalent method, which have to use the interest rate as the basis. So it is important to identify the suitable interest rate because the interest rate is fluctuated over the time, and you have to make sure that the interest rate that you use in your calculation is reasonable. Okay? And then the next one is changes in money value. For example, the cost of material which is used now probably will not be available 30 years from now, or suddenly there will be surge in cost of labors, so which we can't predict. Eh? So the changes in money value is very subjective, but normally the person who has the um, good knowledge and also a vast experience can predict these sort of things. If we compare to the young QS or just graduated QS, the accuracy is less compared to more experienced uh, QSs. And then the last one is obsolescence. So obsolescence is when the object cannot function adequately due to rapid changes in economy and technology. So demolition works only done if the building can't be renewed anymore. It's not conducive. It's decaying, and the site needed for other purposes, which I think we have discussed lengthy in the previous chapters about urban decay. Okay, this is the differences. I think you can read it on your own. I will give the slides, PDF slides later. Okay, okay, the same. The form of obsolescence. I think you can read it on your own. Okay. So the type of maintenance is also self-explanatory. So you have preventive, you have planned maintenance, you have preventive maintenance, you have corrective, and so on. Corrective when something that you don't plan happen. It broke, then you have to replace. Preventive maintenance, for example, for light bulb, you estimated lasted for 2 years, so every 2 years before the bulb is kaput, then you change the light bulb. So before the things broke. Okay, the disadvantages of LCC is number one, it's difficult to determine accurate maintenance and running costs because we can only predict for the future, and it's also back to the experience of the person who prepared the life cycle costs. In Malaysia, generally speaking, life cycle cost is not really being practiced comprehensively in Malaysia. There are JKR have initiated an LCC research. I think in early 2000s, but um, at the moment I think that they don't have the proper life cycle cost database to share with us. I don't know whether they have, but using internally. But as far as I'm concerned, um, they are not doing it, because most people still look at the construction cost, the initial cost, rather than the overall cost, the LCC. The second one is difficult to choose suitable interest rate. So as I explained earlier, the interest rate is fluctuated. So to find a suitable interest rate is hard, especially nowadays. For example, when COVID-19 happens, the Bank Negara has reduced the overnight OPR. So the interest rate is going down and down. So nobody has expected that this pandemic will happen in Malaysia. So that is why it is difficult to choose the suitable interest rate. So when the interest rate um, is less than or more than what we have projected, the cost that you have calculated will not be accurate anymore. Similarly apply to the tax rate. So if the tax rate is fluctuated over time, either marginally high or marginally lower, then your calculation in your LCC will be inaccurate. Okay. Next one is inflation. So we can't sure how what is the inflation rate in Malaysia, where it involves a lot of materials, import export of materials, when it involves a lot of labors. So labor cost per day might be increased significantly. We are not sure about the future, about 20 years from now. Nobody can predict the actual cost. So the inflation may so interest rate, tax rate, inflation, these three is correlated. And if there's something wrong with your prediction, then your life cycle cost will not be accurate. Okay. And then next one is the future costs influenced by demands and trends. So if the demands and trends have changed, for example, um, you are building a shop lots, for example, so because demands now change from brick and mortar shops, now people are preferring to buy online. So there will be lack of potential customer for your buildings. So in the end, your future investment, your future income will be less than what you expected. Okay, and the last one is the lifespan of building prediction may not be accurate. Okay, we are not sure whether your building will last up to 60 years or 99 years or 45 years. Again, these advantages can be remedied if the person who um, produced the life cycle cost has vast experience and has a good knowledge on the market, on the construction costs and so on. So the more experience the person who do the life cycle cost, the more accurate it will be. Right? Okay, we stop here and we continue with the valuation table in the next video. Thank you.